Ladies and gentlemen, this time I will give you a report titled "Parking Space Recognition Based on Deep Convolutional Neural Network". This report is divided into 6 parts, namely Introduction, Relative Work, OpenCV, Pre-treatment, Network Model Structure, Experiment, Conclusion. The first part is Introduction. Parking space recognition refers to capturing images through a fixed cinema, using the captured images to determine the changes in parking space and the total number of vehicles in the parking lot in real time. This is a key task in the field of target recognition. Because of its wide application from field surveillance to target tracking, it has attracted widespread attention in the industry. Real-time recognition of parking space is essential for the development of an intelligent society, but there are still differences in this part of the research. This paper processes a real-time detection and recognition method for parking space based on deep convolutional neural network VGG19 combined with SENet model. The premise of this method is pre-processing by OpenCV. Compared with other methods, this method does not have interference-free images for eternization, but uses single-frame images extracted from the video of processing, so the prediction of the model interference is actively eliminated, and the prediction accuracy is 95. Since it is based on single-frame image processing, our method has good generalization and can be extended to more fields. The second part is related work. The core technology of finding vacant parking space in parking lots through video frames captured by surveillance cameras is to quality identify vacant parking space in parking space. In this paper, though a lot of analysis of the existing domestic intelligent parking lot management system parking space detection technology, comprehensive advantage and disadvantage, found that virtual detection algorithm based on the imagined filters of virtual and empty parking space can be well applied to large area of outdoor parking lots. An image processing system based on video frame objects is proposed. Use the deep convolutional neural network VGG19 SENet to enhance virtual target filters, improve accuracy, and reduce loss. The information conclusion function can help drivers find free parking space quickly and accurately, save time to look for vacant parking space, and operate as little traffic resource as possible. The third part is OpenCV pre-treatment. In order to improve the accuracy of parking space detection results, we need to perform imaging pre-processing on the parking lot video frame collected by cinema, so as to achieve the purpose of removing redundant information in the image and improving the readability of the parking space images input to the network. In this paper, The pre-processing of the parking lot video images includes mathematical operation to remove noise and to obtain the ROI error of each detection feature by fitting a straight line. Image denoising is a process of reducing noise in detected images, sometimes called image denoising, to improve the image signal-to-noise ratio, so that the imaging quality in the input network is better. In the paper, due to the influence of optical characters of the cinema and the lighting change of the capture video, there is a certain amount of noise in the collected parking map. In order to prevent noise from negatively affecting the final parking detection during the training model, the key is eliminating noise. Noise removal is divided into parts: coarse filtering and fine filtering. First, the dark spots and the extreme color emission in the top view of the parking lot of this paper are binarized according to the threshold, performing with-and operation on the processed image and the original image. For the photo of parking lot, median filter is generally used for the first processing to filter out most irrelevant factors. Fine filtering mainly uses the kernel operator in the OpenCV library to perform an detection on the grayscale image of the parking lot. The working model is mainly to detect the horizontal and vertical of the image and the technology process of the operator to obtain the horizontal direction Gx and the vertical direction Gy respectively. The purpose of the first order derivative well is to obtain the index dimension binary image that can express the pixel gradient intensity G and the gradient direction, thereby obtaining the index dimension binary images of the overall range of the parking lot. The above work can complete the conversion of RGB images of the complex parking lot of the image denoising tasks that can clearly distinguish the image of the parking space and the part of the car outline, which is more suitable for machine processing. After obtaining a cleared parking space image and the cultural images in formula, the main goal of this section is to select the fixed range of the parking lot by the method of straight line filtering, and use a operator for the image culture of the binarized image. The demonstrate feature extraction allows them draw the extract positive of the image of the parking space, then divides each chain space into cluster, and finally divides each parking space. Fourthly, the boundary corner points of the parking lot are selected to determine the general run of the parking lot, multiply boundary line equation, and updated by linear fitting through each corner point. The master image of the parking lot is drawn, and the image after image detection is matched through the master operation to obtain the required ROI images. The first part is network model structure. Figure 4 shows the overall structure of the SENet network, which mainly contains the sequencing model and the extension model. The sequencing model performs the convolution operation in a local space and endorses all special filters on the channel into a global filter. This paper uses global array pooling as a first step. Complex arrangation methods can also be used. The extension model is an operation that iterates the relationship between channels. After OpenTree, the global description characters. It has two characters. First, it is very flexible and can obtain the nonlinear relationship between each channel. The second is the linear relationship can be fused, allowing multi-channel filters to be learned. Network structure. The VGG19 SENet network structure is shown in Figure 5. After the input image is 48,48,3 is entered. First two layers of convolution are performed to obtain 48,48,46, and one layer of pooling output is performed 48,48,128. The output image obtained after 5 rows of convolution and pooling operations in the field is 1,512. Then enter the SE network for filters enhancement. Finally, add a full connection layer and use the softmax function for output. The fifth part is experiment. The prediction of parking space in this paper is based on two parts. The first part is to use the OpenCV tool to pre-process to obtain the point coordinates of each parking space, input the point coordinates into the model, and predict each parking space through the model in each frame of the image. The second part is to design a VGG19 SENet network structure through the SE network and imagine data generator class twice to enhance the images to improve query. After basic pre-processing, the key is to classify the point coordinate into collectors. Divided the parking lot by conclusion, divided the parking lot line equivalently and coordinately in dust each parking space. For our VGG19 SENet network, after experiment, we adjusted the conclusion curve to 343 and the step size to 1, and the predicted experimental results were the best as shown in the figure 6. This sixth part is the conclusion. This paper proposes a method of VGG19 SENet network to improve the accuracy of parking space recognition. This method first uses OpenCV processing to color imaging. OpenCV coordinate through Polytechnic transformation and then uses a new network model to predict the parking space. The key point is to use SENet network and imaging data general class to enhance the packet filter twice to improve the success rate of small target detection. This is a method that has never been explored in the crude technology. For this reason, we have added the SENet model to the VGG19 network. The function to classify and strengthen the filters after the output of the full connection. layer of VGG19 to make the experimental results better. By comparing the experimental results of different networks and the prediction results under survival interference, the effectiveness of the method is to verified, which is better than some concurrent method. In addition, experimental verification shows that our proposed network has good generalization and can be applied to different scenarios. Thank you. This is the end of this report.